Okay, we are going to do 11.3. The last one for this week. Get my pencil here. Okay, so we are 11.3. Now, so far, we've been working with exponential equations, okay? Meaning, and by the way, my glasses are broke, that's why I have these on, okay? Meaning, if I said 5 to the what is 25, we're solving for x. And before, now you might know it's 2, but the last lesson, remember we looked at it as what base can we put this in? Well, we can put this in base 5. So that gives me 5 to the x equals 5 squared. And if bases are the same, you can set exponents equal and solve. So exponential equations can be rewritten in logarithmic form. And I'm sorry, this is supposed to be a y. Okay? They can be written in logarithmic form. Where, now, let me write this in a different color so you can see it. This is what we call the base. So there's the base. Okay? And then this is the exponent. Notice where it is in the log. And this is the answer. Notice where it is in the log. Okay? Now those always are like that. So, for instance, 5 to the x equals 25 can be written as log base 5 answer equals exponent. So log base 5 of 25 equals x. And we knew x was 2, so log base 5 of 25 equals 2. Now, I'm warning you now, after this section, 11.3, you're going to need your calculator. You're going to need a calculator that has this button, that has, I think it's that button is like the second function of it, and it's going to have this, and that is second function. E to the x is the second function of ln, and 10 to the x is the second function of log. And then with this calculator, you'll also have one that says this, and that's the to the key. It's either this or this. So in other words, if I wanted to say 5 to the second power, you could put in your calculator a 5, then push this, or this, whichever one you have, then push 2, then push equals, and you'll get 25. You don't have to go 5 times 5 times. So if it was, say, 2 to the 6th power, all you'd have to do is press the 2, then press the button, that's the to the key, and then press the button 6, and it should come out to 64. That's 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay? So, to the key, you need a log and an ln key. And what happens is this little thing right here will be right above it. It's just the second function. This little thing will be right above it. Okay? You're going to need that, so get that. $12, $15 at the most on sale, maybe even $9.99 right now with school happening. Okay? All right. So, let's say I had 3 squared, and we know that's 9. How do I change that to logarithmic form? Log base 3 answer equals exponent. What if I had 1/5 to the negative 2 equals, no, does not equal that. Excuse me for just a minute. Yes, Ruth?
Humanities 213, 223, has any of that been changed recently?
No.
Okay, so we're still going with the syllabus that Troy has?
Yes.
Okay.
Uh-huh. Okay, so log 1/5 to the negative 2 equals 25 would look like this in log. Log base answer exponent. And same thing, what if I said log 10 of 100,000 equals 5? Changing that the other way around to exponential would be base answer. There. Okay. All right. And does 10 to the 5th equal 100,000? Yes, it does. Okay. So if I had log 4 to the 164th equals negative 3, what would that look like exponentially? It would be 4 to the negative 3 equals 1 over 64. So you need to be able to go back and forth. Okay? Now, with that said, let's see what we're going to do with it. Now, they're going to give you an equation. It's an equation because there's an equal sign. They want us to solve for a variable. It's x. I have no idea how to solve this, but I can change it to exponential form, and then maybe I can solve it. So what I say is, when in doubt, switch it out. That's my little mantra. So exponentially, it would be 4 to the negative 2 equals x. So 1 over 4 squared equals x. So x is 1/16. Didn't know how to solve it there. Changed it to the exponential form, and we solved it. When in doubt, switch it out. Okay, so what if I had log base 3 of x equals negative 3? I can't solve it this way, so I switch it out. Base, exponent, answer. X is 3 to the negative 3. So 1 over 3 cubed is x. So x is 1 over 27. Okay. What if I had log 1/2 of 3x plus 1 equals 2? No idea, but let's change it. That's really 1/2 squared equals 3x plus 1. So 1/2 squared is 1/4. Solve for x, move that over, so I get 3x equals negative 3/4. Divide by 3. Now stop and think about it. That is negative 3/4 divided by 3, which is negative 3/4 times the reciprocal. That cancels out, and I get negative 1/4. So x equals negative 1/4. We solved it. Okay, let's look at some more. What if I had log x of 3 equals 2? All right, switch it out. Base, exponent, answer. Well, how do you solve for an x squared? You take the square root, and whatever you do to one side, you take to the other. So you get x equals. Now remember, when you take the square root of both sides, you got to leave a plus or minus, and then the answer is plus or minus the square root of 3. Solved. Okay, so it's changing the logs into exponential form and solving. Log 49 of the cube root of 7 equals x. All right, switch it out. 49 to the x equals 3 times the square root of 7. Now, do you see where there's a common base here? 49 is 7 squared. That's easy. We got to think back to where we took this and the square roots. Remember, that was the same as saying 7 to the 1/3. So 7 to the 1/3. So I get 7 to the 2x equals 7 to the 1/3. Now, are the bases the same? Yes, they are. So we can set exponents equal and solve. So you divide by 2. So you have 1/3 divided by 2, which is 1/3, times its reciprocal, which is 1/6. Okay? So we go back to what you're going to have problems like this where you have to find the same base like we did yesterday, or you're going to have problems that are just basic. It's solving all the ways that you've learned how. If they put it in logarithmic form, you change it to exponential form, and you solve. Now, there's only one exception, it's not an exception really, it's a shortcut. One thing they want you to know, there's two rules that make it easy. If you have this or this, base and this number are the same, or whatever the base is, this number is 1. If you have log 8 of 8, log 10 of 10, log 9 of 9, log 6 of 6, log y of y, log a million of a million, as long as these two are the same, your answer is always going to be 1. And anytime this is 1, this base can be whatever it wants. Log a million of 1, log x of 1, log 6 of 1, log 9 of 1, log 53,286 of 1. The answer is always going to be 0. Because think about it. Switch this out. Base, exponent, answer. Does anything to the first power equal itself? Yes. Here, base, switch it out. Base, exponent, answer. Does anything to the 0 power always equal 1? Yes. So, if you were to see something that looks like this, log 7 of 7, what's your answer? 1. If you were to see log 8 of 1, what's your answer? 0. And those are like two exceptions or shortcuts or ways to always remember. You can switch it out, like if someone said, what's log 8 of 8? What does that equal? You go, well, 8 to the x equals 8. X equals 1. Or someone said, what does log 9 of 1 equal? Well, you'd have 9 to the x equals 1. Any number, what does it have to be to what power to equal 1? 0. Okay? So, just two shortcuts. All right, and that's 11.4. You need to get used to that because the next thing I'm going to be showing you is how to solve it when it's in logarithmic form, which is a little different. Okay, so you need to know how to switch it out and solve an exponential form in all the different ways you've learned how to solve. And then we'll go to logarithmic form. Okay? All right, have a good day.